This is a puzzle called Fun Run by WombatBreath. I got it from the Sudoku Testing Submissions channel on the CTC Discord. Um, yeah, I don't think there's anything else I need to say. Let's just hop into the rules. So it's a regular Sudoku, meaning obviously usually there's 3x3 boxes, but instead the regions are, well, irregular, I suppose, and are divided by the dark black line. So instead of usually the 1 through 9 being here, the 1 through 9 has to be there. Similar for this has to have the digits 1 through 9. And wait a minute. Oh, no, I can't do math. For a second, I added that up and came up to like 11. Nope, still only 9 digits. That would have been bad if there were 11 or something, 11 cells in there. I wouldn't know what to do. Okay, so that's the first step. Then the next step is, oh, yeah, diagonal. So the marked diagonal here has the digits 1 through 9 as well. So if we discover, let's say this is a 5, we can't then put another 5 down there. It's basically like another region. It's just along this marked diagonal. Then the next step is arrow Sudoku. So let's look at this arrow right here. The digits along the line of the arrow add up to whatever's in the bulb. So if we discover this is a 3 and this is a 5, then this would have to be an 8. Similarly, or kind of oppositely, if this is a 7 and this is a 4, then this would have to be a 3. Because 3 and 4 add up to 7, of course. They did mention in the post, on the Discord, I mean, that there is some ambiguity intended with these arrows, so we can't tell, like, does this arrow go here, 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 or does this arrow go over here? I'm not sure how F puzzles will take that into account, because unless they're cosmetic arrows, it'll tell us right away, or it could tell us right away which way it goes, but we'll see. So then the last step is the, oh yeah, it even says here, note that some arrows are deliberately ambiguous. So the black dots are ratio dots. They're also sometimes called black Kropke dots, but yeah, ratio dots works just as well. So between two black dots, or sorry, between two cells, if there's a black dot, then the two digits must have a ratio of 1 to 2. So if this was a 3, this would have to be a 6. If this was a 2, this would have to be 1 or 4. And not all black dots are shown, so that's good. And yeah, I think that's it. I'll put the link to the puzzle down in the description, and let's just get into the solve. So the first thing I see with this puzzle is these two runs of black dots. When you have a run like this of 3 cells separated by 2 black dots, it must be 1, 2, 4, 8 with a 1 or 2 in the middle, and 2 and 4 both must appear on this line. And also, yeah, that's just how it goes. And so we can do the same thing down here. So 1, 2, 4, 8, and the middle one can't be 1 or 8, and this is 2 or 4. Or sorry, yeah, in there is 2 or 4. So we now have a 2-4 pair, so this can't be 2 or 4, which means this must be 2 or 4. So this is either going to be 1, 2, 4, or 8, 4, 2. So that's handy. I'm going to color those lines. I just want to make sure I remember that. These lines might mess with my scanning a little bit, so I just want to make sure I'm... Actually, let's change this to dark green, and this is light green. So light greens are the same, and dark green is the opposite. Okay. Is the opposite of the 2 4s, I mean. So this arrow, this can't be an 8. Which means, could this ever be a 1? No. Could this... How does that change things, is basically the question. This can't be 8, 4, 2. If this was a 2, this would break, because this would have to be... Yeah, this can't be a 2 any longer. Let's see. So this... If this was 4, 2, 1, this would be a 3, and one of these digits would be a 9. If this was 2, 4, 8, this could be a 3 or a 5. If this is 1, 2, 4, then there's a couple more options. I might have said that wrong, I'm not sure. But I don't know if there's anything else right offhand that I can derive from this. Yeah, I don't think, I can't quite see it, if there is something. Hmm. So we might have to use what I call geometry. I think that's the right term for it. I say what I call it because I don't know necessarily what everyone else calls things. I sometimes not the best in that regard. So if we look at the top 3 rows of the grid, we can see that we have 2 full regions here, one in the top left, one in the top right, and we have most of a region kind of in the top middle. But then we have 2 cells poking out. Let's just actually just color this. We have 2 cells poking out and then 2 cells poking in. And it turns out that these 2 cells, the 2 magenta cells, have to be the same as those 2 cells, because we have 3 full sets of the digits 1 through 9, because we have 3 rows of 1 through 9. Or yeah, we have 3 full rows, so we have 3 full sets of the digits 1 through 9. If we subtract off these 2 full regions, we will have subtracted off two sets of the digits 1 through 9. So that means yellow is one set of the digits 1 through 9. Now this is most of a region, and these are just the 2 extra cells. Well, this one region is missing these 2 extra cells, so these must be the same. Don't know offhand how helpful that is. Did I? Oh, I meant to just... Well, let's make them red. I don't really like the hot pink, but I think it goes well with the yellow. So that means this can't be a 2 or a 4. Because these can't be 2 or 4 because they're already in the thing. Maybe I should be looking down here because I know a little bit more information about this. Very slightly more information about this. Oh, yeah, obviously, this can't be an 8. Yeah, that's where I should have looked right away. I said that up here, that this couldn't be an 8, but the same holds true down here. This can't be an 8 because you can't put 8 on a 3-cell thermometer, or 3-cell thermometer, 3-cell arrow. We just finished doing a thermometer puzzle. I guess I have thermos on the brain. So that aligns things like this. So this is a 4. This is not a 4. Actually, this is 8. Like this. You can get rid of those colors. And I see a lot of things going on right now. So the minimum that this arrow can be, we don't know which is the bulb, but the minimum this can be is 3, 5, because all of this is the same region. So we can't reuse 2 or reuse 4, so 3, 5 is the minimum, and 1, 3, 5 adds up to 9, which is the maximum, obviously, for a single digit. So one of these is a 9, we don't know which. We can do a little bit better. You can never have a 5 on a black dot, because you can't take half of it. It would be 2.5, which isn't allowed, or double it, because that would be 10, and that isn't allowed either. So this is 3, this is 5, and 3 always goes with 6. I just saw up here 2, 4 on a 3-digit arrow must be 1 or 3, which will give 7 or 9 as the bulb, but we don't know which is which, so that's all I can do there. Actually, no, this is a 3 looking up here, so this is a 1. One of these is a 7. Okay. Let's look this. 5 on this arrow actually, I think, provides a lot of information, because you can't do very much with a 5. I mean, obviously the maximum is 9. So these two have to add up to at most 4. So it's 1, 2, 3. This can't be a 3. We can repeat digits on an arrow. So these could both be 2s, and that would be a valid answer. Or these could be 1, 3. Like, they don't have to repeat, but they could repeat. As long as they're not in the same region or the same column or row. Okay, let's see. I'm just thinking, because this is another 3-cell arrow. which means it either has a 1 on it or it's 9 and 2, 3, 4. And if we could say that there's definitely a 1 on it, then this is definitely the one. But it could be 2, 2, 4 up here and then 3 down here, because the 2, 4 rule out from that. So I think this is just 1 or 3. It's a 1 if in basically any case, or it's a 3 in this very specific 2, 4, 3 case. So if this is... So what could this be? This is 7 or 9, actually. Just because it can't be 6, can't be 8, and the minimum for a 3-cell arrow is 6. If this was 1, 2, 3, it would add up to 6. And actually, this can't be 7. Because if this was 7, that would require 1... That would require 1, 2, 4. I don't know why I selected that as well. But it would require 1, 2, 4, and we already use a 1 or a 2 up there. So this is, in fact, 9. Though we don't know the arrangement. It still could be 3, 2, 4, or it could be... Well, it couldn't be 1, 2, 6. So it could be 1, 3, 5, which would go exactly like this. Or it could be 2, 4, 3, which would go like this. But either way, we're using the 1, and when combined with this 1, 2 cell, we use the 1 and we use the 2, both. So this must be 8 or 9, right? If this arrow over here, the one on the left, adds up to 9, the one on the right adds up to 8 or 9. So these could both add up to 9, or this could be an 8 if this was 1, 2. I don't know if I've had this pink there and I keep looking at it like it's going to do something, and it has not done anything yet. That might have been a little bit of a waste of time. So what's left in this box is 6, 7, 8, and 9. And this can't be a 6. I don't know how helpful that is. That might not have... Oh, this is just a 7. Of course, that was just a 7, because 2 plus 7 equals 9. The more you know, huh? So I know one of these adds up to 7. If this adds up to 7, this cell can't be 1, 2, or 4, because this can't be 1, 2, or 4. So this would be 1, 2, or 4. This would be 3, 5, or 6. Oh, no, there's an easier way to do it. So if this was a 7, we said that this arrow adds up to 7. So this, one of these bulbs is a 7. If this is the 7, then this will be 1, 2, 4. But we've already used 1, 2, and 4 in this region, so that can't be. So this is not 7. This must be 7. This is 6, 7, 8, or 9, and we just said it can't be 7, so there's a little bit. Actually, this line can't have a 2 on it. Right? Yeah, we have a 2 down here looking up. We have a 2 just above looking down. So this can't be 6. And no matter what, it's going to have a 1 on the line, because the 2, 3, 4 case is ruled out by these 2's. So there's going to be a 1, which is restricted based on this 1. If it's 8, it must be 1, 3, 4. So this would be 1, 3, and then 4 over here because of this 4. If it's 9, it must be 1, 3, 5. So the 1's are still over here, but I think it's a little bit more variety. And actually, I just noticed this 7 looks down and removes the 7 from there, so this must be 7. That's the last spot in the region. Let's see. If this is 8, this must be 3, 5, like this. Does that break anything? Feels like it almost does, given the number of 3 5s over here, but I don't think it does. At least, not off the top of my head here. So this is 8, this is 3 5, because this... Oh no, that's wrong. Anyway, I was thinking it couldn't... Yeah. This couldn't be a 7, so this couldn't be a 1, but it could be 2, 6 still, if this was 8. And plus, there's still the whole case of if this is 9, so I don't know if that's useful to look at. Let's look... So I was just thinking, this cell in this top middle region must go here, unless it's an 8, in which case it goes here. But that's not helpful, I don't think. I thought maybe we could put like, oh, if this must be 9, that's at least a digit in the grid to help, remove options. So what's here? If this could be 3 4. If this is 9, this could be 3 4. Or it could be 1 6. Or this could be 8 and be 1 5. That is a lot of options. Okay, here's something that geometry actually will help us with. So these are 3 full rows down here. So this means we have 3 full sets of the digits 1 through 9. If we remove these, we now have yellow as 1 set of the digits 1 through 9. And we have almost a full region here. We have everything besides 7, which is the 1 protruding digit. So this must be the 7. Another way to think of it, rather than looking at full sets of the digits 1 through 9, is look for protruding and intruding cells like this. So if you imagine a line just right across here, luckily where a lot of this region line is, this thick line here, only a 7 is protruding, so that same digit must be intruding into that area. So both of these are 7s, which I haven't thought about this line across here at all yet. But I don't see how it would be helpful at this point. But definitely something to keep in mind. I've just noticed that 7 must go down here in the corner somewhere. What's left in this column is 2, 7, 5. That actually does help. This 7 rules 7 out of here and here. So this must be 7. So this is a 2 or 5. So this digit... That doesn't really help. I was just thinking this cell right here sees both the 2 5 on the line and 2 5 in the region, which must be opposites of each other since they're in the same column. So it could restrict this from being 2 or 5, but I don't know how helpful that would be. This can still be 1, 3, 4, 8, 9. Yeah, that's really not helpful. Not helpful at all, but something good to recognize, I suppose. Am I missing something? Oh no, there's 5 digits. Okay, I was thinking there were only 4 open cells, but there were 5 different digits between these 2 cells. I was like, wait a minute, there must be something I'm missing here, but nope, there's just 5. So this is 3, 5, 6, 8, 9, and this is not 6. Does that help at all? So this is 3, 5, 6, 8, or 9. And obviously that can't be a 9. But could this be an 8? This is an 8. This is a 1. This is a 2. This would have to be a 5 then, because this is a 9 arrow. I don't see why that wouldn't work. Well, one thing, this can't be an 8-9 pair. If this was an 8-9 pair, we would have an 8-9 there, which would break this cell. So at least one of these is an 8 or a 9. for whatever that's worth, I guess. um, oh, this cell right here can't be a 5 because it also sees both of these. That doesn't help immediately, but maybe it'll pay off. Oh, and actually, neither of these can be 8. That's even better. That's the way that I should have looked at this. Yeah, 8 sees both of those cells, so this can't be 8. So 8-1 breaks that way. Okay, so this is 3, 5, or 6. For this to be 6, this would be 2 or 3. If this was 3, then that would put a 6 here, which would break the puzzle because there'd be 2 6s. So if this is 6, this has to be 2, and this has to be 8. 2 here and a 4 here would break the puzzle because it would have to be 8, 2, 2, 4. If it's 6, 2, 1, this could be a 5, and that would be fine, I think. Yeah, I don't see anything wrong with that. Oh, one small thing, 7s are over there somewhere. Yeah, that's not really helpful. 7s are in one of the highlighted cells in that row. I'm just noticing that we have a lot of 7s, so I'm trying to keep on top of that. Hmm. Oh, sorry, I just hit my microphone. What are the options for this cell? If this is 6, this must be 2. If this is 5, this could be 3 or 4. And actually, this can't be 3. If this is 5, this can't be 3. Because that would put a 6 here, which would then break this line, because we're adding to 8. If this is 3, this can't be 5, and it can't be 6 either. Oh, 3 just doesn't work. If this is 3, this would have to be 5 or 6. 5 can't be on a black dot. 6 would put a 3 right next to the 3. So this is never a 3. So this is 2 or 4. So this is 1, 2, or 4. Can't be 8 because it's on a 3-cell line. If this is a 2, this has to be a 5. If this is a 4, this has to be... Yeah, if this is a 2, this has to be a 5. Because it can't be a 4 to add up to 8. If this is a 4, this has to be 3. Because it can't be another 2 to add up to 8. This is a 1, 2, this would have to be 5 to add up to 8, or 6 to add up to 9. If this is 1, this is 2. No, this doesn't... 1, 6 doesn't actually work. Because if this is a 1, this is a 2, which makes this a 6, and this an 8. So this has to add up to 8, which makes it a 1, 3... Or, what? Sorry, a 1, 2, 5. Huh. That felt helpful when I said it. I feel like this is just, like, right on the verge of breaking open. There's just something that I'm not seeing. Is it something down here, maybe, to just totally change how I'm thinking about things? I don't see. I feel like it must be up here somewhere. Three, 5. So this is 3, 5, 6, or 9, which is fine, unfortunately. If this is 4, this is 2, this is 5. 4, 2, 5, which makes this a 5. Yeah, this is a 9. What if this is a 6, this is a 2. Wait, I think that... I, how does this get to 4? If this is a 4... I just said this works, though. No, it... Whoops. This doesn't work. Yeah, so if... Let's go through. If this is a 4, this is a 2, which has to go with 6. 4 goes with 3, but now this arrow adds up to 9, and this arrow adds up to 8. So this is not 4. So we've guaranteed a 2 on there, although I don't know if that's helpful. So if this is 1, this is 1, 2, 5. How does this become 3 now? Without using that 4 that we just wrote out, how does this use a 3? I don't think it can. Because at most this adds up to 7 with 2, 2, 3. So this must be a 5. Okay. So that's not a 5. Does not quite rule this out, unfortunately. Can we maybe do something here with protruding... Nah. So these 3 cells... Whoops. These 3 cells are the same as these 3 cells? Is that... Oh, wait a minute. That does actually help. That means this can't be a 5. If I'm correct about this. Whoops. The 7s are the same, obviously. Yeah, I think that's the case. These 3 cells protrude over the line, so they must be the same as the 3. So this can't be a 5 then. So this is 1, 3, 4. And I think 1 must be in here. Because this... Sorry, 1 second. Throat is a little raspy tonight. Yeah, 1 must be in here. So 1 must be in here because there's 2 2s looking in at this 3-cell arrow. So if this can't be 5, that rules out... I don't actually know how helpful that is. It means that if this is 1, 3, 5, the 5 has to be here, and the 3 has to be here. Oh, wait, that is actually something. Okay. So if this is a 5, this must be 1, 3, 5, which puts a 9 here. Then we look over here, this must be 6 because there's a 5 here, but 6 goes with 2, and obviously 6 plus 2 does not equal 9, so this can't be 5. This is a 3, which makes this 1, 3, 4, which makes this 8, and is going to give us a lot of information. This can't be 3 or 6. We do know there's a 6 in here somewhere, though, because we've realized that's a 6. So this is either, yeah, 5 or 9. Oh, there's a 1 right there. That doesn't order this at all, but actually I think we can get rid of these colors now. I don't like keeping colors around for a long time because I feel like it affects my scanning a little bit. I'm sorry about my chair if you can hear it. I try not to move very much, but it's an old chair that's very, very squeaky. And, like, I moved my leg like 6 inches just there, and I think it squeaked very loudly. So apologies for that. I feel like there's something more right here that I just am not seeing, but it should be stupidly obvious. That's one thing about, like, I don't know, 90% of Sudokus is that they're not hard, like, individual things are not hard. Individual steps, I should say, are not hard, are not super difficult. It's just you have to ask the right questions in the right spot. So, like, if you just miss something, it always feels like it's a, oh, that was a silly thing to miss. Why didn't I, like, look at where 9s can go in this bottom region and have that somehow, you know, break open the puzzle. But it's just, yes. 1 is right. Oh, that's actually a little bit helpful. 1 is in one of those spots. Have I figured this out yet? Not quite. Maybe there's some more geometry I can use. So this will be the line, the left side of this will be the line. So this protrudes, and this protrudes, and this protrudes. Oh yeah, that's very helpful actually. And these three don't. So this is a 5, which makes this a 9, and this a 5, and also makes this a 9 because that must match there. Okay, let's get rid of these real quick, and that one as well. So that must be the 2. This can't be a 9. This is the 8, this is the 5. What's left? 3, 8. Oh yeah, there's a 9 right there. I was gonna say it definitely feels like something should be affecting this bulb. I just couldn't quite see it. Okay, so this adds up to 8. So this line adds up to 8, which must be the 1, 2 that we talked about, I don't know, half an hour ago almost. Actually, probably closer to like 15 minutes ago, but... So this is the 1, 2, and these... Whoops, no, actually I want that. These two must be different, for whatever that's worth. Yeah, I'm not sure how helpful that is. Oh, actually, more helpful. 2s, look over into this box and force that to be a 2. So that resolves a lot and forces this line down here to be the 2, 4, 3, or 2, 3, 4. In this row, we need a 1, 4, and a 9. That can't be a 1 because of that. And this can't be a 1 because, whoops, can't be a 1 because of that. I guess also because of this one over here that I didn't even notice. It's one thing that happens with a regular Sudoku, is just your scanning is just fully thrown for a loop. And you can't just, do what you've always done. These can't be 1s because of this can't be 1, or this can't be 1 because of this, so then this is the 1. This can't be 5. One of those is a 5, I don't see how to resolve that. 3 7s, I don't think there are any looking over here. What's left in here is 2 5. It doesn't quite help. Oh yes, it does. There's literally a 5 next to it on the diagonal. And that 2 resolves down here. This can't be what can this be? One thing I like to do is just type in all the digits and then just remove them as I see them, because otherwise I feel like I'll like miss an option. And then 8 and a 9. So it is just a 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So then this is a 3 over here, and this is an 8. What's left in this box? 1, 2, 3, 4, 6, 7. This must be the 6 because there's a 4 and a 7 in the column. What's left in this column? A 1 and an 8. What's left in here? 1, 2, 3. 4 must be up here. 5. We need a 6. Unfortunately, it can go anywhere. No, it can't. There's a 6 on the line there. And there's also a 3 on the line, so this can't be a 3. And then 9 can go over here. So this must be a 4, this must be a 9, this is 6, 3. Resolved fully, nice. This is 6, 7 over here, and there's a 6 right here looking in. This 7 makes this resolved. This is 2, 3, 9. There's a 3 up there looking in, and there's a 2 right here looking in. Not quite enough to finish it off. This column right here, this must be a 4 or 7, and there's a 4 right here, so this, whoops, this must be the 7. This column needs a 5, 6, 8. This must be a 6 because there's a 5, 8 here. This 6 looks over. 5, 8 is all that's left, that's fine. 2, 9, neither of these can be 2, so this must be a 2. What's left is not 4, 6, 9. There's a 6 right there, and a 9, I suppose. This row, this can no longer be a 1 because of this. We can actually diagonal. I don't know why. I just turned my head to look at that. I don't know why I tilted my head. Whoops. 5, of course. This must be a 5. Doesn't quite resolve that up there yet. This is a freebie as a 3, and that, whoop. I'm just misclicking now as I get towards the end of the puzzle all the time. There we go. There were some harder parts, but not as hard parts. I think that was probably like a 2 out of 5 difficulty, I think. I think if I haven't done any regular Sudokus in a while. If I had, I think I would have realized I needed to look at uh, geometry much more often, and it would have just like immediately recognized the spots to look at them. Anyway, that was a fun puzzle. Thank you, WombatBreath, for the puzzle, and thank you guys for watching. Have a good night.